Greetings retro enthusiasts, welcome. So this is test number 2. Yep, you're looking at my desk. Chill. So in the last video, test number 1, well, stating the obvious again, oh well, I asked everybody watching what you guys are using for compiling and assembling. That information would be wonderful right about now. Just drop a comment in if you will. I've got hold of, I think it's Z80. Apparently that can assemble a Z80 code. So might just have to use that temporarily, or at least for the time being, because the next step, test number 3, is to actually program something meaningful. So yeah, I'm getting to that point. However, we've had a mail delivery. Yes, snail mail. First of all, I've got 5 of these puppies. Yeah, I know you can't read them, but you can see the Z. Yep, these are Z84C0020 PECs. They're the Z80 CPU that runs at 20 MHz. Oh yeah. So the clone that I've got that I'm running at the moment, which is kind of, well, I won't shed a tear, let's put it that way, if it blows up. Runs up to 6 MHz. These puppies, which I have 5, not quite sure what I'm going to do with the other 5, the other 4 I should say, but I'm sure there'll be projects and builds and whatnot. These ones go up to 20. Looking forward to playing with them, but that will be much later. Much later, because at 20 MHz, gonna need PCBs. But that's them. And I also got these. Put them that way around. I did manage to invert the video last time, so everything was the right way up for you guys. So these little things, hopefully the video will be high enough resolution that you can read them, but just in case you can't, these are IS61C1024. They are 128K times 8 high-speed static RAMs. And by high speed I mean 15 nanoseconds. That's 15 nanoseconds access time. Oh yeah. Looking forward to playing with them. Yes, I know they're 128K, Z80 can only access 64K. Whatever. They're fast. But that's what's come in the mail since the last video. But I have something else that kind of indicates much later on where this project is going to go. And that is a pair of these puppies. Ooh. Yep. Pair of Motorola CPUs, MC68010s, P10s. Oh, looking forward to playing with them. Nice, big system with a lot of RAM. But that's not all. After these, there's something else that I've got. I have another little puppy, and this one is little. It's an MC68030 RP33. Yep, it's a 33 megahertz. Oh, yeah. Looking forward to playing with this one as well. But this is a PGA chip. So yeah, gonna need a socket and PCB for that. That's okay. It can wait. Play with that and have some fun. So, test number 2. Well, fun and games has been had, to say the least. I did mention this thing was portable, didn't I? So let's go and position the camera. Right, what we're going to concentrate on is the LEDs. So they're there. Nope, not that way, this way. So what do we have set up? Well, Z80 is fully connected to the bus. The Supervisor is fully connected to the bus. And the RAM is fully connected to the bus. So, updated the Supervisor program. So it will now make the Z80 release control of the bus. And for that, we're going to demonstrate. And power up. So all the pauses have been grossly exaggerated. So you can see it's just running now. It's on a 10-second pause. So we hold reset down. Bus requests come high. Now the bus acknowledge isn't coming up because the CPU is in reset, which is fine because in a moment it's going to release the reset. And bus acknowledges come up. And now you'll see the data lines go. And then we release bus request, reset the CPU, and then release it. And as you can see, CPU starts running. Now there's garbage in the RAM. Hopefully that's from the 10 seconds that we allowed it to run right at the beginning. Now I could have sworn this RAM initializes as FF. Could be wrong on that one. But as you see there, it took control of the bus, it sent some data, and then released the CPU. Right, ran into a problem. Yeah, over here, let's see if we can get there. Oops. There's the LCD and those cables. Yeah, the LCD is not connected. Discovered a huge problem with these HD, is it 44870s? It's the 20 lines, 20 characters by 4 lines ones, both standard ones. And I believe the 16 by 2s are also going to have the same problem. It's the Hitachi chipset on them. Yeah, these brown wires here, they're the data lines from the LCD. Those LEDs are connected to the data lines via a resistor pack pulling them down, and the LEDs are on. That's a problem. Yep, the chipset has weak pull-ups in them, and the weak pull-ups are strong enough to override the memory chip. So it caused all manner of problems when the Z80 had control over the bus and was reading from memory. That's a problem. So yeah, even though the supervisor was writing stuff to the LCD, and we know that code works, we had to have the LCD disconnected from the bus. So right now, the problem is we can't connect the LCD to the bus system. It has to go to a driven system. Even when the enable line for the LCD was in deselect mode, so inactive mode, it was still trying to pull the bus up and succeeding. So we can't use these LCDs. Looked into basically a driver circuit for it, and while yes, we can do that, the latency involved, the increase in latency was ridiculous. So it's like, no, we're not going to do that. So what we had is the LCD lines are disconnected, and we're not going to use LCD. Instead, I reserved the two of the 4 hardware serial lines in the chip, in the supervisor. So we're going to have to use a serial console so that we can tell what the supervisor is doing. And I'm going to have to set that up before the second part to test too. Yep. The supervisor program right now, while yes, it takes control of the buses and it sends some information over, it doesn't try to access the RAM. So this is kind of an intermediate test to make sure that it's going to do what it's supposed to before I try and access something. So part B, which for you guys will be after this section, for me, I'm going to have to write some code for the supervisor. And so what we're going to do is we're going to do a memory test. And that will be in part 2. Literally right about now. And welcome back for part 2. For you guys, it has literally been a split second. For me, it's been about a week. So, where am I up to? Well, I'm just going to power up and explain as I go along. So you can see by the LEDs, it's doing something, it's counting. Well, Supervisor's powered up, taking control of the bus, and is currently doing a memory check. So at this point it's writing to memory. I just realised IO request is lit up. Huh, curious. IO request. That is... That's coming from the Z80. That's interesting. And we've also got a partial read. Yep, there you go. Z80 is doing things that it shouldn't be. That's weird. Let me see if it'll do it again. Power down, power up. That's better, it's behave now. Weird. Anyway, the Supervisor does a walking one's memory test on the lower 16 kilobytes. And that is what it's doing now. It does take a while. But for testing purposes, I thought I might as well do it. So it writes a specific byte into memory, reads it all back, and makes sure that what it's reading back is correct. Now it throws up some fails randomly, but they're not actually fails. It's hard for me to put it in words. I'm going to show you the PuTTY terminal. Yep, here we have a serial link. And of course this port right underneath my finger is serial to USB. It's a very weird one, but I actually find it useful to actually use that one because it's got other things on it as well. But as you can see, successfully taking control of the data bus, the address bus, and the IO bus. And there we go, IO request is lit up again. That Z80 is doing weird things again. Looks like it's trying to read from IO. Anyway, a few things I've got to iron out with the read and write process from the Supervisor. Biggest one that I've had to get around is the latency between updating the ports in software and the propagation to the actual latches was far too slow. And in fact, it was causing things to not get updated because they were being switched far too quickly when accessing the RAM. So I had to change the software to directly write to the latches on the Supervisor rather than going through ports. Now there is still a latency there on the data bus because the data bus is bidirectional. So it has to use port because the latches are for output only. So yeah, kind of an issue there. Need to get around that one. Yep, just watching the putty screen, some of these RAM failures that it's coming back with are actually quite amusing. It's almost like the Supervisor has like Alzheimer's or something. Or should say the silicon version of it. But there we go. 16 kilobytes RAM test is done. But because of the failures, it's not fully released the Z80. It's released control of the buses, but the bus request is still up, and that's on purpose. Because if memory fails, it doesn't want to start executing stuff. So I'm quite happy with this. It's not perfect, but it is working. So over the next week or so, I'll be tweaking things and solving these random failures that are actually failures. And from that point, we then need to write a piece of software to go into the Z80. The question then becomes, other than the LEDs that you've been looking at, how do we know that software's running? You're going to have something for the CPU to control, send data to, something like that. I do have an idea on that. But thank you, those that have actually given me information and helped me out. Most appreciated. If you have any comments, suggestions, questions, feel free to drop them in the comments below. Look, take care, have fun, and I will see you in the next video. Bye for now.